Shahan, and in today's lecture we will continue with our the data types in Scala with second part, in which we will cover null data type, nothing, any data type, any reference, and any val. So and at the end we will also discuss the what to say, the basic hierarchy and the interconnection between all these data types. So for a longer run, we would understand what is extending what is a superclass of what. So in future, it would also help us to understand the significance of each data type as well. So without any further ado, let's start with null. This is actually not a data type, but an instant of trait. So trait of what? Null is a trait, as it is mentioned, it is a trait, okay? And this small n, null, start with a small n, is an instance of null, instance of this data type. So this is actually data type, this is not. Okay, so this is an object or the instance of this class, or the trait. In Scala there is a specific what to say, in Java, let's say we have interface which would have unimplemented methods. In Scala we have trait which can have implemented and non-implemented method both, which is called trait, and null is one type of trait. Okay, null would have can have methods, implemented methods or unimplemented method, but usually null doesn't have any method or value. This is because of the property of null, but it is a kind of trait. Okay, if it doesn't have a value or it doesn't have a method, okay, then it means there is no point to extend the null as well. So null is a data type, but in what scenario we can use this null, and this null instance of null. So we will see the difference of using null and null start with capital N. What are the basic uses of both of these? Null is as an instance and null as a data type or a trait. We will come to each of these points one by one, but let's first explore what is null. Okay, as it is saying, it has no field, no methods, and no null reference. It would refer to a null reference. Okay, and also it is a kind of instance of trait null. Okay, so what it means to be a null trait? Okay, the instance of trait null. So let's explore this through an example. So first we are exploring null. Okay, so in order to do that, let's define a variable. Let's say null reference variable, and we can have it as a string. Sorry, string, and we can assign it. We can have it null. Okay, because we want to understand the meaning of null. And one thing what we will do, we want to check the length of this. So if I simply save this program, and if I simply compile it, so it is the main method, so it would simply print. If everything is okay, then it would be printed over console. Okay, so something is wrong. Okay, something is wrong we have done over here. If we can understand what is wrong, then we can understand the use of null as a reference. Okay, this is starting from small n. Okay, so let's focus on this part. What is the meaning of this error? This is saying it is null pointer exception. You don't need to read everything over here. You just need to see, okay, what is the type of exception? It is saying null pointer exception. So it means it is saying that you are trying to access the length of something which is null, which is not possible. Okay, so if something is null, it means there is no such object of that reference. Okay, this string is null. It means it has nothing to take the length of. So if you are calling this method, it would say it is a null pointer exception, because you are accessing something which doesn't exist. Okay, so it means this null is actually the null reference. That's why it is saying it has no field, no method. Then what is the point of accessing those method? Okay, this, if you are saying something is null, it means that variable has no field, no method, but it would be the instance of trait null. Okay, and no reference as well. Null reference, it is saying that it belongs to null reference. Okay, so this is actually the null reference. But if you want to explore this one, okay, this would start from capital N. Okay, and it would be different from previous one. Okay, that is why in Scala two types of such keywords are there. Okay, this is actually the main difference. If I would like to write, it would be, it is a data type. Okay, but this one is not data type, it is instance. Okay, so this would be a instance. If you as you can see over here, this is actually the instance. So let me write it as it is. Okay, so this, it is actually an instance of trait null. Okay, so how to define this null data type then? So what I'll do, I'll again try to, so I'll use the same name, just one change. Maybe let's say dt would be the data type, and instead of making it as a string, we can, what we can do, as null is also a data type similar to string, right? Then we can define null over here. So in that, what will happen if I simply perform the same logic over here? Just let me do this dt. So what will happen uh, if I call this? Okay, do you think the error would come? No. The reason is, what we are saying, null is a data type. Okay, null is a data type. The error would definitely come, but not the null pointer exception. The error would come because the it would hold the same properties. Okay, it would hold the same properties. See, null also no field, no method, null or empty is reference, as you can see, the similar to that. And also you cannot extend or initiate this. Okay, and it is a trait. Okay, it is a trait, but definitely if you have created something as a null data type, it means it exists, but it doesn't have any method. Okay, it means the existence is there, but it doesn't it doesn't have any method, any field. Here the difference is, it said it doesn't exist as well. So forget about accessing the length of a string as well, which is actually null. But here it would say without. Okay, what we can do, we can run. So let me comment these. Okay, and save it, and let's compile. And okay, so the error, it is saying that no such member or method, value length is not a member of null. It means it is saying no such method. But here that it is different. It is saying null pointer exception. It means you are trying to access something which doesn't exist. Okay, in which would not have any memory. So this is the difference. Okay, between small null and capital null. And actually you can see null is the data type as a string. Okay, and that data type is actually null. So that's why it is not throwing a null pointer exception, but still it is throwing that such method doesn't exist, because null also wouldn't have any method and field. Okay, we will see the usage of all these data types in our assignment, upcoming assignment, or in the practical as well. Okay, whatever the practical or the task we will be covering, we will try to use we will have some kind of usage of all these data types, including null and null. Okay, let's come to other data types as well. Next one is nothing. Okay, we have covered null instance, null data type, and now it is the time to cover nothing, any, any reference or any variable. Okay, so let's come to nothing. Nothing is more precisely, if I would say, it would say no value at all. Okay, it doesn't have any method or any value. Okay, nothing actually extend any data type. We will see how and what is the meaning of that. We cannot use nothing as a return type of a function except in the case where the function throws an exception. So nothing is actually related to any val. Any val is means something value. It is related to some values. Okay, but definitely it has no value. It means we have different kind of data types. Okay, let's say we have 9 type of data types. Earlier we have discussed byte, character, integer, float, and all sort of things. So if we want to generalize all these data types, okay, then we can consider something as a nothing. If we pass something as a nothing, it means it can be byte, it can be integer, it can be float. It is more similar to the void we use in Java. Okay, we will let's see through an example. Okay, but before going further, let's understand this hierarchy a little bit. As you can see, nothing at the lowest part, and nothing is actually extending all these data types, double, float, and these are all value type. It means these are all any values. Okay, and nothing is actually extending all these values. It means nothing actually, it wouldn't have any method, it would not have any value. But then if it doesn't even have any value, then what is the use of using nothing? Let's see, that is very important question. Then when to use nothing? If it is not it doesn't have any significance, then why to use it? Okay, a very specific case when your function is throwing an exception. It means you have designed a function which would whenever you call that function would throw some exception. So what would be the return type of that exception? It would be nothing. Nothing means, because nothing would extend all the, as you can see in the hierarchy, all sorts of values it can extend. Okay, all sorts of value it can extend. Nothing is some kind of a data type which can extend all sorts of data types. Okay, nine data types, as you can see: double, float, long, int, short. So it means it can return anything. It is extending, it means it can return anything. Okay, and the use of nothing would be, more specifically if I would say, the best use of nothing is whenever you write a function which can return an exception, you type nothing as a return type of that function. So let me come to the code part. Okay, so as you can see, we have written something for nothing. It is saying log exception. So this is user defined function which would which would actually return nothing. And as you can see, we are throwing an exception. So whenever you call this method, whenever the program counter would start executing this function, it would eventually return a exception. So it means something, some type of return type. Okay, some type of return type of a function should have. Okay, so in that case you can use nothing, because it is the subtype of all the data types. It means it can return anything. That is the very important point, because it is extending all your data types. Okay, as you can see in the figure as well. Okay, as you can see, nothing would extend all the data types which are actually associated with some value, any value. Okay, we have 2 types of data type. One is these simple type of data type which would store values. Okay, and some other data types over here, as you can see, which would store actual objects, user defined objects, or primitive objects. And but nothing would actually have this thing, that it would subclass, it would sub part of all your data types. So it means you can return anything. But more precisely, the use of nothing, we generally use nothing in a Scala whenever you throw an exception. This one thing, you can keep this in your mind. Okay, you have to write something over here, right? integer, string, unit. But when you are throwing an exception, make sure that you always write nothing. Okay. So if I simply, because I'm not calling this function, right? That's why it would not throw any error. So if I simply call over here, it would throw an exception. Okay. Throw an exception over here with some message. Now let's come to any. This is very interesting. But first you need to understand this, that any is divided into two parts. Okay, two subparts. First one is any val and the second one is any reference. Okay, as you can see in the hierarchy, any is at the root, it would be at the top. It means anything in Scala, anything, whether it is double, float, integer, nothing, or null, anything would have this as a superclass. It means any is a root class of everything. Okay, everything you use in a Scala, whether it is any value or any reference, as you can see, as it is divided into two parts. So and any val or any reference. So value, whenever you try to store some values, you would use all these 9 data types. And whenever you use any reference, it means you would try to store some objects or list or option, or your class would also store some, would take some memory in the heap or so. Okay, it means any is the super class. As you can see, any is the super type of all types, or any in the super class, any, or I would say this would be any is the superclass of all the classes, as you can see over here. Okay, everything would extend any somehow. Okay, whether it is any val or any reference. So these are divided into two parts. Let's come to understand what is any reference and what is any value. So as you can see, all double, float, long, int would extend any value. As you can see, list, option, your class, wherever there is a memory for object is involved, you would try to refer something as a reference. Okay, so whenever such things are there, you, whether you use any val or any reference, they both would extend any. Any is actually superclass of everything, right? That is the point. As you can see, all non-value types are defined as a reference type. Okay, it means wherever there is a reference, it would always extend any reference. So this is the key difference between any reference or any val. Any val represent value types. Okay, so value types could be double, float, long, and short, byte. All these 9 types of data types. Okay, as you can see, val c and any val equal to 1. Okay, and as you can, this is similar to the integer type. Okay, as you can write over integer, you can define one is an integer. So the genuine question should come into your mind, that what is the difference between any val or int over here. For that, we need to understand this through a program. Okay, so that we can understand the actual meaning of any ref or any value. Okay, in order to understand the depth of where to use any ref and any value, let me show you in the program. Okay, just hold on. So as you can see here, there is a function which is which would have any val as a input parameter, and the definition of this function is simply printing the x, whatever you would be passing as a parameter. The same goes with the any ref and then the any. Okay, as we have discussed, any can, you can pass any. As you can see, either you can pass any val or any reference, it should accept. When you pass any val, it can accept any of these as an input. But when you pass any reference, it can accept list, it can accept option, it can accept null as well, it can accept your class as well. Okay, it means when it comes to any, you can pass anything, whether list, option, your class, or null, nothing, or all these data types. But when it comes to any val or any reference, you can pass, for any val, you can pass all these primitive data types. And for all these for all, any reference, you can pass anything would come over here. It means whenever you calling, let's say you're calling f, so you can pass anything. You can pass here integer, you can pass even the character. Okay, you can pass even the character. this would be accepted. Why? Because here any value would accept anything you would pass as a primitive data type, because everything would be extending any val. Okay, this is the simple concept of Java. Any reference can accept anything. This is a G function which can accept anything. So here uh, for for the reference I have created a null variable dt. So what I'll do, I'll simply pass that. Okay, this would serve the purpose, because any reference, either you pass list option or your class, or I'm actually directly sending null, so it should accept. Third one is any. This H can accept anything. H can accept even this one as well. Okay, so it is, as you can see, it is accepting value and it is also accepting reference. So it means any would can print, any here can print as a data value or a data reference, but G can only accept the reference type. F can accept any primitive data types listed over here. You can pass anything, okay, integer, character, or anything. So without any further ado, let me save it and let me compile it. Okay, this thing we have to comment. So we will see the output. Okay, so it is simply printing that statement, and now 2 null C null. Okay, so why it is printing 2 because 2 is an integer, 2 is being considered as a character. This would have the value as a null, which is, it is showing null. H is this one. It can you can pass any integer, any primitive data types out of 9, or you can pass even the reference which we are passing over here. That's why it is C and null. So guys, these differences should make you understand that when to use any, when to use any value, any reference, when to use nothing, when to use null, and when to use null as an instance. So all these things are a little confusing in Scala, but very important. Whenever you would be having a good hands-on Scala, you should be aware about all these things. So if you would have some doubts, so don't worry. Okay, in our doubt session, or in our practical session, we can discuss your doubt. Okay, but if you this is my request to you, please go through this video more than one time. Okay, more than, at least you should watch this video twice. Okay, everyone, this is for everyone. Then you would have the depth of when to use null and all these data types. And these are data type which is not usual. If you remember that in Java we have already used integer, byte, character, and string, but these data types are quite different, and you should be master of the depth when to use all these. Otherwise, you cannot use all these data types. Okay, you would go with the simple data types you have been using. Okay, so this is all for today. Okay, if you have any doubt, you can comment down below. And thank you so much, guys, for today's lecture.